So as we talked about previously, humans are really the only species that truly show exponential growth in our population. And so you can see here our J-shaped curve graph. And in the beginning here, our population was growing very slowly. At that time, we were hunter-gatherers, and it was very difficult to survive. It was also difficult to grow very large families because you were constantly on the move. And so eventually, people settled and started farming, and we saw a little bit of an increase in the population. And then here we see a little dip due to the plague. And then right here is when things really took off with our population. And if you know anything from history, what happened about that time was the Industrial Revolution. And with the Industrial Revolution came more people living in cities, more jobs available, medicine, food was readily available. It was easier to have larger families. People were surviving longer and having children themselves. And so we saw our population just explode. And so we see that drastic increase in the human population that is continuing to rise. It's started to slow down a little bit, but we are still increasing drastically. Most population ecologists predict a population somewhere between 7.8 and 10.8 billion people by the year 2050. So we're already somewhere over 7 billion, so my guess is it would be towards that upper end. So as I said, our population is still increasing, but things are starting to slow down. And we can see that here with this growth rate graph. And you can see that they are projecting that our growth rate will continue to decrease. And so as it continues to decrease and get closer to zero, we start to approach that zero population growth, which is really what we want. We want to level out and not continue to increase quite so drastically. Just as a little point of interest, this dip here around 1960, that is when there was a famine in China and about 60 million people died. So we saw a big dip in our growth rate at that time. So all countries move through something that's known as the demographic transition as they move from being a developing country to being developed. And we see very distinct patterns related to their population growth as they move through these different stages. So we start with stage one, which is called the pre-industrial stage. And at this point, as you can see in the graph, the birth rate and death rate are both high, and they fluctuate quite a bit. This is a fairly rough period of time for most countries because there's not very good medical care available. Sewage disposal is very poorly handled. So people get sick a lot, they die a lot. People are having a lot of babies, but the babies don't survive. And so we see this fluctuation of, again, very high birth and death rates. And so as you can see, the population stays very low and you see very little growth. But then they move into this transitional stage, stage two. And this is as they're becoming developed. And during this time, we see the death rate decline because now they do start to have access to food, adequate sewage disposal, clean water, medicine, all of these things. And so people start living longer. But they're also still having a lot of kids. And so the birth rate remains high while the death rate drops. So with a high birth rate and a low death rate, you see that exponential growth, that very fast, rapid growth during that stage. So then once countries become developed and are in stage three, or the industrial stage, that's when we start to see birth rates decline, mainly because of access to birth control and a desire to have smaller families. And so we see that birth rate drop to where it's, again, roughly equal to the death rate, but now both of those are fairly low. But the result is the same because birth rates and death rates are roughly equal. The population stabilizes and levels off. Then some countries will move into what's called the post-industrial stage, which is stage four. And a couple of things can happen here. They can either level off and fluctuate roughly around that zero population growth level, where the birth rate and death rates are equal, or you see some where the birth rate will actually drop below replacement level, and that's when you start to see a population decline. So let's talk about replacement level for a second. What that means is that the population, in order to remain stable, people must have enough children to replace themselves. So if you have a couple, a mom and a dad, they need to have 2 children in order to replace themselves. Now, in reality, replacement level turns out to be somewhere around 2.1, and the 0.1 is not because you can have 0.1 of a kid, obviously, but it's because not all children will survive to reproductive age themselves, and so you kind of have to have a little bit more than 2 kids on average per family because not all will survive and reproduce themselves. So in order to maintain that zero population growth, some people need to have 3 kids and some only 2, most only 2. So the problem with dropping below replacement level, we see this in China. Japan. Japan is dealing with this issue right now because they have a high number of old people, but very low numbers of kids. They're not having as many kids because people are focused more on their careers and aren't as interested in having families. And the problem with that will come as people get older and need to be supported financially. You run into economical issues because there isn't a large enough workforce to help pay for the elderly. And so you really don't want to get into that declining situation because of some of those economical issues that will be faced. You really want to stay in that zero population growth phase. Age structure diagrams or population pyramids are another way of looking at a country's population growth. What it shows is the amount of males and females, the percent of males and females in each age group in the population. And it works as kind of a bar graph moving out from the middle, with, in this case, the females to the right and the males to the left. And what we see is countries that are experiencing rapid growth, if you notice, the base of their pyramid is very wide. And what that means is they're having lots of kids. And those kids, once they reach reproductive age, they're also going to have lots of kids. So when you have that wide base and the narrow top, that tells you that you've got rapid population growth. When countries move into that transitional stage, we see the base start to narrow a little bit as those birth rates decline, as we saw on the previous slide. So that's where the population growth starts to slow. And then you have your zero or declining growth populations, which are going to be your developed countries, where if the pyramid is a little more shaped like a column, more even up and down, that's going to be your zero population growth situation. Or if the base is actually narrower than, say, the middle of the graph, kind of what we see in this one here, that's when you're going to have declining growth. So you can tell from the shape of the pyramid what type of growth that country is experiencing. One of the things that will have the greatest impact on a population's growth is the life expectancy in that particular population or a particular country, since we're talking about humans here. So life expectancy is the average number of years that members of a population are likely to live. And in industrialized countries, we tend to see higher life expectancies because of the things we talked about previously, safe sewage disposal, adequate food, access to medicine, things like that. So you see life expectancy increase in those countries that become industrialized or developed. But it turns out that one of the greatest indicators, or one of the greatest, the things that have the greatest impact on life expectancy is infant mortality. And that should kind of make sense, because if you think about the fact that it is an average number of years in a population, then if you have a high infant mortality rate, that's gonna bring that average down, right? So in the graphs here, we see that When infant mortality is low, life expectancy is higher compared to a high infant mortality and the resulting lower life expectancy. So again, those can be fairly well tied to whether or not a country is industrialized. So we talked before about populations or ecosystems having a carrying capacity, the maximum number of individuals that the ecosystem can support. So when we're talking about our global carrying capacity in terms of human population, scientists estimate that being somewhere between 10 and 15 billion people. And that's based on many factors, including the amount of habitable land, available farmland, average yield of crops, and diet, things such as that. So you can actually click on the picture here and it will take you to the US Census website, and you can see the rate of increase in both the US and worldwide and kind of see where we are right now. So the reason that they give a range in terms of the global carrying capacity of 10 to 15 billion people is because not everybody uses resources equally, and depending on how we use those resources and how we maybe change our habits and our behaviors to use resources more wisely and more equally, that could change the amount of people that Earth can support. So there's something called an ecological footprint, which basically estimates the amount of land and water area required by each person. And you can, once again, click on the picture here and it will take you to a website where you can take a quiz to find out how many Earths would be required if everybody lived like you.